Hey there, welcome back. And to this, our section on queries. We finally stepped up to the big leagues and are going to start studying select statements. Great fun. As you well know, we've been toying with these things for the last three lectures here because we needed to validate our triggers as well as verify what we had done with respect to inserts and updates. We're finally going, though, however, to start looking at these things in a more formal fashion. This and the next lecture are going to be covering single table selects. We're then going to move on to joins, both inner and outer. Subqueries will be handled in the next section, both correlated and uncorrelated. We'll then give a lecture on union and intersection, culminating on discussion of the select statement with what I'm calling the advanced select options, things like if then else, case, and hierarchicals, things like that. Great fun. We're going to have a lot to cover in only, I think, 6 lectures, so hang on to your hats. This one's going to actually be a pretty straightforward, though, because a lot of this you will have seen before and probably picked up just through simple osmosis. All right, with respect to the resource materials on this one, please go ahead and pause. Make certain that you've got lecture 12 selects.txt open in your favorite text editor and you're logged into Developer as my store so you can be following along. Okay, great fun. Let's begin. Okay, let's go ahead and look at this very first query in our lecture 12 script. Select product description, product name, and quantity on hand from products. Boy, they don't get any more straightforward than that, do they? What do we have here? Looks like we start with the keyword select, then a comma-separated list of field names, the keyword from, and finally a table name. Couple of things to check out. First, no reason to put the fields in the same order as they appear in the table's metadata. Any order is fine. Next, no need to use any specific case. Finally, no need to use all the fields. We have only a subset here and everything's going to work just fine. All right, let's go ahead and execute this guy and see what we get for results. Really no surprises here, right? We get back all 5 rows from the products table, and we get back exactly the 3 columns we asked for in the order we listed them in the select. Cool beans. Seems like we're working right. All right, now let's execute that exact same query, but with the addition of column aliases. A column alias is nothing more than an alternative return name for a column. In our case, we're going to relabel the product description field description, shorten the product name field to simply name, and use the standard abbreviation for quantity on hand. That's QOH. Check out our results set now. The new column headers now reflect our aliases. What's the rule? Use aliases on 0, some, or all the columns. It's entirely up to you. All right, let's move on. Let's look at our next query. We've been using this one all along despite not knowing exactly what it does. Select star from product. Select asterisk from product. Database geeks always call this one star. The asterisk here is equivalent to saying, give me every field from the products table and give me them in the order of the metadata found by system. Hey, no surprises here, right? We've been using this syntax all along. Now we officially know what it does. Note, no option to change the order of the fields when using the asterisk syntax. You're going to get them in the same fashion that system has them in the metadata. All right, moving on to something a little more interesting. Our next select reads, select no rum as sequence, row ID as disk ID, and product ID as ID from products. Again, we touched on some of this previously, but let's go over here to make certain everyone's following. Here we are saying, give me the row number and disk address associated with every product ID. Okay, easy to see where that information would be valuable. Now remember, row num is a function of the sequence or the order in which product rows were returned. Let's look at it more closely. In fact, let's change the order of the rows returned in the last query and see what happens. We do that by using the order by clause. In this case, we are ordering by the product ID field in a descending fashion. Note, ASC is the default, so you never have to specify the ASC or ascending qualifier. Looks like the row num came back the same way, which is what we would have expected, as it is nothing more than a row counter. However, now we've reversed all the disk and product ID fields. Please, I want you to understand how that worked. If that's slipping away, take a minute and think about it, and you'll get it. A special note here on what happens when you don't specify an order by clause. In general, when you have a single table query without an order by clause, you'll get back the rows in the order of the primary key, even if you've not included it in the query. However, don't bet the farm on this generalization, particularly if the table has many rows broken across multiple partitions. When you've got large tables or multiple tables in your query, there's no determining the order of rows returned unless you specifically specify an order by. What's the best method for establishing the order of the rows returned under any condition? Specify it through an order by clause, thus ensuring you get what you need. Now that you know this rule, there's another warning about performance. Don't use an order by clause on huge record sets when accessing a shared database. Sorts are huge resource hogs and are better performed on a local computer than a shared server. All right, moving on. Only two more variants on the select statement and we'll wrap this lecture up. Our next variant in the list is the distinct keyword. Let's start our analysis of the distinct keyword by going out and getting the suggested price and quantity on hand field for all rows in our products table. As expected, we get all 5 rows, but please note how the suggested price for 2 of our rows is $3.99, while it's $5.99 for 2 of the other rows. Similarly, 3 of the rows have 10 units on hand. Now let's change things up and get the distinct suggested price fields for the products table. Cool, just what we expected, 3 distinct price rows. Play the same game for quantity on hand. Yup, just as we expected, just the 3 distinct values of QOH. All right, anybody want to guess the data set for our last distinct query? Sure. We're going to get 4 rows because the query returns all distinct combinations of suggested price and QOH. Again, that's a little subtle, so if you weren't able to follow along, please just give it a second to review it in your mind. Maybe go through it in terms of explicitly figuring out what you would have expected. The thing to remember here is you're looking for unique combinations across all the distinct field specifications. All right, moving on, we're going to wrap this first lecture up. Oracle select functions. Check out this first little query here. Select product name, suggested price, floor of suggested price as floor price, and the trunk of the power of suggested price, comma 0.5, comma 2 as square root, all from products. Any guesses? Well, the floor function simply says remove all decimal portions of the number. The power function raises the first value to the power of the second parameter, and the trunc function truncates a decimal number value in parameter 1 to the value of decimals specified in parameter 2. Given that definition, all of a sudden our results sound perfectly reasonable. What about this next query? Select sysdate plus 8 and power 250, comma 21 from dual. Well, we've touched on this one just briefly in earlier lectures. Dual is simply a fake table owned by system and prived to all users. Dual always returns a single row of data as specified by the literals and/or functions you include. Very handy little guy when you need a quick calculator on dates and/or obtuse functions. By the way, Oracle has a function for just about everything you can imagine. Need one, just Google it and it's likely out there. Think about Excel and you're going to do just fine with respect to the available function sets. Just as easy. All right, gang, that's our intro to the select statement. We kept it real easy in this lecture with selects on a single table and either a simple field list or the asterisk, just as easy as we can get. Let's summarize what we hit. We started with select comma separated field list from table name. Elementary. That's how do you get to Oz? One step at a time, and that's where we started with that. We then looked at aliases associated with some or all of our columns. Easy to use and very handy, particularly when you're running long functions on some of these table names. It's easier to call them something meaningful. We then looked at select asterisk from table name, which of course brings back all the fields in the order as specified in the system metadata. Our next set of queries looked at row num and row ID, important stuff. We then changed that up a little bit by order by clause being placed on that same query. And of course, row num did not change, whereas row ID did, because we're in fact reversing the order in which the rows were returned to us. Remember, the important thing associated with the order by clause is you want those records returned in a specific order. Go ahead and specify the order by clause, because that's really the only way you're going to ensure it. As to performance, please don't do those sorts on huge record sets on a shared database. Bring that record set back to your local computer first and then do the sort there. Remember that as a programmer, hugely important. DBAs are not going to like you if you do set sorts on huge record sets on a shared box. It's not a great idea. We then went on to an introduction to the distinct function and how it actually returns a set of unique combinations across the specified fields. Then went on to briefly discuss functions, how they get utilized in Oracle. Basically, you can use them either in the field list or in the where clause, which we'll learn about in our next lecture. But for now, please understand that there is a bunch of them out there, and if you can think up a particularly math-oriented function, date-oriented function is probably out there. Finally, we concluded our discussion with a brief introduction to the dual table, dual really being owned by system and prived to everyone, returns a single row associated with the literals and or functions that you specify in a select. Just basically putting a calculator into your database, either to be used on numeric fields, some character functions, but not as many, a ton for date as well. So go out there and play with that guy and get used to using them, because it's an important part of SQL, particularly the select statement. All right, gang, that concludes our first lecture on the select statement. Queries are going to start getting much more complex going forward, so look forward to that. In the interim, please study what we just took a look at, because we're going to be building on that going forward. Also, go out there, have some fun, but learn something every day.